everybody, we're going to talk about isotopes today. Isotopes are essentially, in layman's terms, or everyday talk, isotopes are different versions of an element. So when you look at the periodic table and you see all of these fabulous elements that we have on there, there are different versions of them. I can have different types of chlorine. I can have different types of strontium. There are different types of hydrogen. And those different types of hydrogen or helium or strontium or calcium, any of these elements, the types are called isotopes. Those versions are dependent on the number of neutrons that they have. Because remember, we cannot change the number of protons. If we have neon, for example, and we change the number of protons that neon has, well, neon is no longer number 10. If we take a proton away, now we have fluorine. So we have to make sure that this atomic number is equal to the number of protons, and that's always going to be true for neon. Right? That's always going to be 10 for neon. But then we have this number down here. This is our atomic mass. And our atomic mass is actually an average of all the different isotopes' masses. So what that means is that if we talk about an isotope, we have to be very specific with what the mass number is. That mass number is a mass specific only to that one isotope. So let's look at a table. I've got a table with some examples. Here's boron, and this is the notation that you're going to see. We're going to see the name of our element, and then this is our mass number. Now, when we look at all of this fun stuff that we've been working on when it comes to isotopes, our symbol can be found on the periodic table. We're going to say PT for short. Boron symbol, if we go look at the periodic table, is right here. Boron's number 5. B. So that's a capital B. Now, when we have our isotopic notation, we always have our symbol. I'm just going to use an S here. On top, we're going to have our mass number. And on the bottom, we're going to have our atomic number. It will look similar to a fraction, if you will, but make sure you never, ever, ever simplify them because we're not in math. So here, for boron, this is nice and easy. They gave us this information. We have our mass number, which is 11. Our mass number is equal to the number of neutrons plus the number of protons in this specific atom. Our atomic number is equal to the number of protons, like we just wrote on the periodic table. So we have 5. So now when we go to say, number of protons, oh yeah, that's right. Our atomic number is equal to the number of protons. So we would have a 5 here. Our number of neutrons, well, how do I figure that out? Our number of neutrons, we're going to take our mass number minus the number of protons. So we say 11 minus 5 equals, and 11 minus 5 is 6. Now this is that tricky part because we know this is an absolutely neutral atom of boron. This has no charge. In a neutral atom, the number of protons is equal to the number of electrons, which means that the number of protons and electrons should be the same too. So that's 3 columns in this little table that are exactly the same. A 5 here also.